So why I believe butterflies prove creation. And part of it is the fact that the Bible tells us that God created all things. It says all things were made through him, and without him was not anything made that was made. And in Romans chapter 1 verse 20, it says this: for the invisible things of him from the creation of the world are clearly seen, being understood by the things that are made, even his eternal power and Godhead, so that they are without excuse. This is Paul saying to people, but if you've not heard of Jesus or you've not heard of God, you've seen creation. And what I want to do this evening is just have a look at a little bit of God's creation and just see how marvellous it is in terms of its design and it's just working in the way it does. One of the reasons I'm kind of interested is that the Greek word for butterfly is psyche. And psyche is the same word for soul or breath. Strong's Dictionary defines the Greek word for butterfly as breath, spirit, the rational and immortal soul. And the dictionary defines psyche as the soul, mind, or personality of a person or group. And synonyms for psyche are soul, spirit, ego, mind, subconscious, self, essential nature, inner self, and true being. So the name that's been given to this small and fragile flying insect actually has the meaning of the essence of oneself. And so I thought I'll have a look at that in terms of doing it. It's never mentioned in the Bible. The word butterfly is never mentioned, although creeping things and crawling things are. But I believe it's still part of God's creation. And I was thinking about the vast wonder of creation. Not quite sure how you kind of imagine this, but anybody know how many different species of life forms there are on the planet that they found so far? 3,500. Okay. Well, it's not billions. It's about 8 million that they've actually found and named as objects. Most of those are single units, some with nuclei, some with not. If they've got a nuclei, they'll have DNA in it. But most of the time we think are, plants and animals and things like that. So how many plants do you think have been discovered and named? Okay? Come on, David. 10 million. It's not a bad guess, Ian. It's about 400,000. For about 400,000, which is not quite so many, really, is it? As you imagine, it is close from there. How many insects, different types, have been named and found? Anybody have a guess? Too many. There's more. Yeah, there's about 900,000 that have been discovered. How many mammals? That includes, various, anything from gerbils to gorillas. It's not bad, 5,400, which means that by far and away insects are the greatest population of the earth. And insects are people. Well, there's 8 billion people, yeah, but there's only one type of people, which is Homo sapiens, so they're not individuals. If you count the individual, insects, you're into billions of them. These are different species of them, so different types that have got different names. Insects are what's called arthropods, which are animals with external skeletons, which is good news. Because if you ever see these horror films where they've got giant scorpions and huge spiders, that would never physically or biologically be able to do that because it just wouldn't sustain that size. Okay, so you're okay. The things that you'll see are fairly big. I mean, they're still a bit scary, but they're not, science fiction scary at all. We have an internal skeleton, and all our bits are connected to the internal skeleton and covered by skin. They have a skin, but it's called chitin. It's the same stuff as your nails are made of. So it's very, very hard, and it's almost inedible. Most things don't eat the skin of insects. And inside that is all the bits that they need to do. So how do arthropods, which are insects, 9 900,000, did I say? Something like that from there. How do they fit in with the various groups of insects? Well, the largest group of insects is actually beetles in terms of numbers of types. But the butterflies and moths come under Lepidoptera. And Lepidoptera is a Greek word, two Greek words actually put together. It means scaly winged. And so every one of the butterflies and moths has scales on their wings, which is why they're defined as scaly winged and Lepidoptera. So how many butterflies and moths do you think there are? Well, there's about 160,000 different types of moths, and there's about 20,000 varieties of butterfly that have been found and named in the world. But they're constantly finding them all the time. In the UK, the book I've shown there, there's 59 different types of butterfly, and there's about 3,500 moths. So we're way behind in the Olympic gold medal stakes for butterflies and moths, but they're there. Where do they fit in? Well, that's where they fit in. The word moth, whenever you mention moth, most people show a little bit of distaste. They make a classic kind of disgust face, crinkled up noses, slightly flared nostrils, But when we talk about butterflies, eyes light up and it's beautiful. They're gorgeous. There's even an official name, by the way, for the fear of moths. And it's called motiphobia. Not mothiphobia, but motiphobia. Well, as far as I know, there's no official name for fear of butterflies. And many people who fear moths find butterflies delightful because they think that moths are annoying. And sometimes they're costly invaders that infest your baking flour and eat your woolens up and bother you by flying around your electric light at nights. Butterflies, on the other hand, are whimsical, they're delicate, they're pure, they're virtuous, they're clean. They needed protection. They're ornamental, and they accentuate the beauty of your garden's flowers. Of course, there's prejudiced versions of what it is. Not all cultures find moths repulsive. Some people actually enjoy them. Others are sustained by them. Aboriginal Australians traditionally hunted for large populations of a moth called a bogong moth. And that's a bogong moth. Okay, it is huge, and they would become semi-dormant during the cooler periods in Australia, and they were traditionally hunted, and they would then be roasted and eaten, or ground up into a protein. And actually, it's good protein stuff. It's clean. I mean, if insects are pretty good sources of protein, you might not want that, but that's, that's true.
Grasshoppers were a clean animal in the Bible.
They were. Yeah, grasshoppers were a clean animal, and locusts. Other cultures might find moths useful in other ways. In Taiwan, for example, there are populations of the atlas moth. That's an atlas moth. You can see the size of it. And I've actually got one here, which is the size of there. And sometimes it's called a snake's head moth. And the reason for that, if it gets frightened or molested in any way, it falls on the floor and it writhes about looking like the head of a snake. When the atlas moth emerges fully grown, then the cocoons, moths have cocoons and butterflies have chrysalises. Mainly because the cocoons are woven and chrysalises are just connected to the stem of whatever it is from there. But Taiwanese use the silk-based empty envelope that the moth was in as a purse. So they carry it around for various bits and pieces in it. And really, there are some large butterflies as well, by the way. This one is 10 inches across. It's called the Queen Alexandra birdwing butterfly. And that's an Australian butterfly. You wouldn't want to meet that in the dark, which is why they fly at daytime. But they're still big. They are massive in terms of doing it. So how do you know what's a butterfly And what's a moth?
Butterflies prettier.
Butterflies are prettier. Antennae, wings. Yeah, the general view is that butterflies fly during the day. They have clubbed antennae and they have brightly coloured wings. And moths fly at night. They have a hairy antennae and they're a drab colour. Yeah, which is true, isn't it? Yeah. So of these two, which is the butterfly and which is the moth?
Trick question.
Well, we're using the taxonomy from there. I'll show you that the one that's on the right-hand side is this butterfly, this one here. Yeah. Okay. Well, who thinks it's a butterfly? Nobody. You see, you all don't trust me, do you, at all? Actually, you're absolutely right. This is the Madagascan sunset moth. That's a moth, which looks exactly like a butterfly, as such. And it's quite a beautiful specimen. And the other one on the side is the dingy skipper, which is one of the English butterflies that you can find. And in fact, it's in the book, so you'll be able to see that. So, I'm not going to bother defining whether they're butterflies or moths. I'm just going to call them butterflies, and they're all in the same thing. There's one thing that actually does help. Almost every moth, there are some exceptions, there are always exceptions, have something called a frenulum, and it's like a hook and eye system that hooks the two forewings to the two hind wings. So when they fly, the two wings are connected together. Butterflies don't have that. They have four wings and they're all independent, which makes them fly from there. And just thought, whoops. This is a kind of structural diagram of a butterfly with the various bits, because they're built nothing like us. They don't look like us, they don't behave like us, they don't even have the same bits that we do from there. So the biggest things that you can see, obviously, are the wings. So they have a front wing and a back wing. And the wings are actually membranes that are close together. There's an air system within that, and they're held together by the wing veins that are there. Sometimes you can see them because they have different colours on them, but most of the time they're there anyway, and that gives a structure to the wing, which gives it the strength. It's three parts of a butterfly. There's the head, the thorax, which is the bit in the middle, and then the abdomen, which is at the back there. And how many legs does a butterfly have? 6. Yeah, because it's an insect. So it's got 6 legs and 2 antennae. It's got something called a proboscis, which is that coiled up spring underneath under its eye, and a compound eye. So that is kind of the structure overall. And what I want to do is to look at some of these bits and just be amazed by how it's created and how it's produced and what it does from there. So let me ask you a couple of questions, first of all.
Is that just one eye?
No, it's 2 eyes.
2 eyes.
Yeah, they all have 2 eyes. With their eyes, they actually have what's called a compound eye. So their eye is actually hundreds of little facets of eyes, which gives them an opportunity to be able to see all the way around without having to turn their head, which is a useful thing to do. Because they're moving all over the place from there. So how do butterflies breathe? How do we breathe? We breathe through our nose into our lungs. Butterflies haven't got either noses or lungs. So
They breathe through their rear ends.
Through their rear ends. Well, kind of. You're not far off from there. They have something called spiracles, which are tiny holes in their body. And the tiny holes in their body bring air in, and the spiracles connect to a system of tubes called trachea, and that carries the oxygen around the body. And if you look at a moth here, I've got one, you can just see where the pointy bit is. You can see those dots along the side. They're the spiracles. And that's how they breathe. They don't breathe in with it like a lung effect or anything like that. They just breathe in. So, let me.
Do they all breathe together, those holes, or do they breathe independently?
They breathe independently, depending if it's windy on one side, they'll get more of it, and if they're moving. And you'll see that butterflies, because they are cold-blooded, they're not warm-blooded like we are, because they have a kind of rudimentary heart, but they don't have the same type of heart that we have. So they're like solar panels. Their wings can not only regulate what they do, but their temperature as well. And it's absolutely fantastic, the structure of a butterfly wing. But you'll see them in the morning, because they don't fly really until it gets warm. And then you'll see them fluttering about. And then quite often you'll see them stop, and they'll either open their wings flat, or sometimes hair streaks, for example, will lean towards where the sun is. And then they'll heat one side up, and then they'll turn over and heat the other side up. And when their body's got enough energy to do things, then they'll fly off and do what they fly from. So here's John.
Does the abdomen flex at all? I was
Yes.
thinking if it flexed, then it would act like a pair of bellows.
Yeah.
And it would suck air in slightly and then push
Yes.
waste air out.
It doesn't do that, but it does do that, but that's not the primary way it gets the air in. So when it's flying, for example, you'll see the abdomen moving up and down as such. It doesn't sort of pulsate, though, most of the time from there. So here's, again, the different parts. I'll show you. We've got a compound eye, one on either side, 2 antennae, the proboscis, 4 legs, mid legs, hind wings, tail, four wings, and so on. And it's got the feet down there. The question is, how do they smell? I don't mean, like they smell awful, but how do they actually taste and smell, given that they don't have a nose and they don't actually have a mouth? Through that little curly thing, through the proboscis, yeah, partly. They are, sorry? Through their feet, yeah. They are absolutely amazing, because each butterfly has thousands of finely tuned smell and taste receptors. And they're all over the place. They're located on their feet. They're located on the end of their antenna. They've got something called palps, which are like residual parts of the mouth of the caterpillar, which is used to make the proboscis, and on their proboscis. So when you look at the butterfly, you'll see that the antennae is, kind of fairly clear, and when you see them nectaring, they'll be touching it with their antennae, and they'll be trampling on with their feet, as well as their proboscis from there. And this is a butterfly, well, it's a moth actually. This is an emperor moth, and we've actually bred these, and they use pheromones, these things from there. So when a female emperor moth is born, she sends off some pheromones, and the males can smell the female and accurately locate them from up to 10 kilometres away. And it's quite a useful thing. You can put them in a little basket, like these muslin, the cake basket things. If you put one of those in there, within about 20 minutes, they're surrounded by the male emperor moths. To put that in context, sometimes where we live, if the wind's blowing in a certain direction, we can smell the chip shop, which makes us hungry, usually on a Friday evening, and sometimes the Chinese. Okay? What they can do is the equivalent of being here in Southam and smelling an individual bag of fish and chips in the centre of London, and being able to fly to it and locate it accurately. This is a tiny little insect that you think, well, yeah, but in proportion to body size and so on. So that's how it would be if we were from here to London. If we were able to smell like them, we would be able to smell it in London. And not only that, distinguish all the other chips and fish shops that you've gone past on the way down the motorway and so on. But it's actually a phenomenal capability, which is why they're able to fly to various locations and find the plants that they need. This is an English butterfly. It's a red admiral, and you can see what it's doing here. It's got its proboscis out, and it's got its feet on the leaf, and it's got its antennae kind of twitching, ready to actually have a look at it. And it's phenomenal how they actually smell, because they use their antennae, they're led to flowers with nectar. While they're flying in the air, they can locate, because the reason they've got two antennae is that they can extrapolate between them, like a GPS system. They can pick out where the flower is, and they know whether that flower has nectar or not. And so they'll fly onto it. When they land, they grab it with their feet and touch it, and that will help them to know which plants are toxic, because some of them actually lay eggs for the caterpillars to eat toxic plants, so that when they're not eaten by birds. And they're generally very brightly coloured caterpillars. If they want to be hidden, then they look exactly like a blade of grass or something like that, or a bird dropping. So they know which plants are toxic, and a female butterfly, when it lands on a leaf, can know if it's the right food plant, so it can identify the food plant. It can know if it's in the right condition, that it's not gone over or not, ready for it. And they can also know whether another butterfly has been there. So these little things that you can imagine while they're there, they've got phenomenal capabilities of being able to work out where to go and what happens and where to lay their eggs when they need to. So, fascinating. We just smell terrible, most of you, but we actually smell very poorly in comparison to things like dogs, but dogs are not anything near as good at butterflies as smelling. So how do they hear? I've given you a couple of pictures of the diagrams of them. Where were their ears located?
Tiny bristles all over which vibrate. With vibrations in the air.
Okay, some insects do that, but butterflies tend not to. They actually amplify it through their wings, but mainly through veins on the wings. So when it hears sounds, that's what it does. In fact, they're pretty quiet, butterflies. I've never heard a butterfly shout, and they're rather quiet from there. But they do hear, and they hear in two ways. One is the veins on the wings, and some have special eardrums. They're used by butterflies to detect birds coming up on them, so they can not only feel the vibration of the bird's wings, but they can hear the slow drumming of the wings. Or in moths have got more kind of better ears, as it were. They detect bats, the ultrasonic that comes in, so they know if there's bats are out hunting, they can move out of the way if they wanted to. So here we've got a butterfly with the little tiny thing. Sorry, David.
I can understand the need to detect birds, presumably predators.
Yep.
I can understand the need to detect bats, obviously. Why moths?
Well, moths normally fly by night, at night time, and so butterflies normally fly by day. So the bats will be out at night hunting them. So if you see dusk time, you'll see the bats flying around. They're looking for insects to try and catch, and the moths can hear the ultrasonic, so then they move out of the way.
I read the text slightly differently.
Oh, okay.
I read it that the butterflies were detecting birds, bats,
Oh, no, it's the moths detect the bats and the butterflies detect the birds. They could probably detect either of them from there. So
Tony,
yeah.
Quick question about the flight of moths and butterflies. You were talking about them being prey to various other animals. You also mentioned that the front and back wings of moths are hooked together.
Yeah.
Are they more agile when they're flying? Because of that, there's a difference in flight patterns between moths and butterflies because of that hooked arrangement.
It's a great question. The question is, do they fly differently? And the answer is yes, they do. But it's not just moths versus butterflies. Butterflies fly differently as well. There's a group of butterflies called skippers which fly very rapidly. In fact, trying to take a photograph of them is hopeless because you sort of, oh, no, they've moved over here. And they go at quite a fast pace. There's some birdwing butterflies which fly just like birds. They've got big wings. There's others that flap around. So it is different for each one, but it's not necessarily moths are different to butterflies. It's just the shape of the wings and their body things from there. So, what do butterflies eat? Nectar. Okay. Sorry? Some leaves.
Or is it just the larva?
Well, caterpillars certainly eat leaves from there.
Sugar.
Sugar water, yeah. From there. Well, let's...
Bananas. They
They eat bananas, yeah. Yeah. Peeling the bananas is difficult for them, though. But they do eat bananas from there. Well, I'll go on to work out how do they eat. And they eat through this proboscis. And this is a hummingbird hawk moth. You might have seen them around because they've been quite common over the last couple of years in this area. And what they do is they buzz like a hummingbird. They can actually move around, stay static and what have you. And they've got quite a long proboscis. You can see it there as it's going into the flowers. Or actually, it tends to be interested in tobacco plants. Not that it's addicted to tobacco, but the smell, the trumpet-like flowers are helpful for it. Yes, yeah, which again is quite a smelly kind of thing. So, how does it work? You imagine you've got a rolled up piece of rope or giant straw and you roll it out again. How would you get the nectar up? Yeah, you'd suck. Okay. The only thing is that it's not got a mouth and it's not got any muscles around it to suck. It's got muscles at the side that will help it.
Surface tension.
Yeah, it's actually, you're quite right, it's capillary action. So what the butterfly does is it lays it can actually kind of suck it up, but it's through capillary action and it moves the sides of it. This is a very complicated piece of engineering. When it's in the chrysalis, the mouth parts of the caterpillar kind of dissolve, and in the same space comes out two portions of the proboscis. It's in two sections, both C-shaped. So when it comes out, it unrolls. The little palps that I've talked about that are there are the things that push them together. So it's a bit like a Ziploc thing as they move it along. And in fact, the system that they work connecting, they've got little hooks and eyes, was one of the ideas behind the invention of Velcro, because it pushes the two together, and sometimes it can be 5 or 6 times the body length of the moth. So when a moth or a butterfly comes out of its chrysalis, it will wait there for a while. It's doing two or three things. One is it's strengthening the veins in the wing to get them hardened, and the other thing it's doing is getting its proboscis sorted out to make it stronger to do that. But it's not watertight, so it's not like a straw. If you imagine having a straw with hundreds of little holes in it, try and drinking up it, you'd have it all down your shirt or down your blouse because it's a bit damp. So they do it with capillary action. So it's quite fascinating. In fact, the physics of it are amazing. And we haven't yet, as human beings, been able to develop the equivalent mechanical structure that will do what a butterfly's proboscis will do. Caterpillars are always at work. They're mashing, they're just eating machines. So they just mash it up, and they don't chew it because they haven't got any teeth, but it all comes in and gets digested. The butterflies have to extract it in a slightly different way. And so their proboscis does it, probes. And here we've got another one of those little skippers. that is doing it. You can see it probing into the individual parts of the plant. And it will let the proboscis stay there. And the proboscis sucks up, not sucking it like that, it's just capillary action. It's a bit like, the COVID test that you do when you put a little drop on and it comes across the paper and turns black or not, as the case may be. It's exactly the same process that works. But it's far more complicated. And I haven't got time to go into it. I've spent hours reading about it and working it out and so on. But what it does is it's a two-way process as well. Because not only do they eat nectar or drink nectar, or I'll use drink because they don't actually do that, but do they collect nectar to process, it's also used for things like getting minerals. Now, the difficulty with minerals is that they're dry. So you can't use capillary action to get things up. So what you have to do, and what they do, is they lay the proboscis on the top of it, and then they dribble saliva down, which then mixes with the thing and comes up. Now, there's another really weird thing which engineers haven't been able to work out, is that the way the proboscis is shaped is that when it starts to get the liquid bit in and it comes up, it doesn't come up as one continuous strand. It actually comes up as little droplets, micro droplets, which means that the tube doesn't get clogged. It's a self-cleaning sucking machine without sucking. And it's brilliant. And it's fascinating to think about that. And as you can see, as I think Rose mentioned, it's not just bananas, but it's fruit that they will do. And the ends, the tip of the proboscis is different depending on what kind of food that the butterfly will prefer. And it's really cool, this, because there are some which are just a nectaring one, it goes to a flower and nectars, has got a fairly straight tube. Those that eat tree sap, I think somebody mentioned about leaves and things, but they will dive in, they'll actually bore their way into bark and do it. They've got like a mop handle on the end of theirs, a mop head, and they will do it and they actually turn it, a bit like one of these things, and it will drill its way in and it will get the sap up and bring it out again, which is amazing. And in fact, don't get too worried about this. This particular moth is a vampire moth. Oh, yes. You'll find it in parts of Africa, so maybe you don't want to go there, but this will actually take up human blood. And what it does, it's quite a small one from there, but it pokes its proboscis in. You can see it's actually under the skin at this point, and it has, in somebody's finger, yeah, that's a fingertip that you can see there, and it scrapes in, and then it pulls it back out again, and on the end of the proboscis there's not only a sharp stabbing point, but there's also backward barbs, and it moves it up and down, which is like sawing through your flesh from there. And it's exactly the same as the fruit-eating ones. So the big fruit, if they fancied you, they could make a nasty hole in it. But that's the same way they do it. They cut it and wreck it that way. So they are massively complicated and ingenious designs.
Where do those ones come from?
Africa,
They come from the Dominican Republic.
No, you're all right. If you're going on holiday there.
They carry disease.
They might do. If you've got, AIDS or something like that, then they're like mosquitoes. They could do that.
Transfer it themselves.
No, they'll just whatever the debris is. So if they've got contaminated blood, they'll give.
How important is eating to them compared with the other things?
Not very much. And in fact, most of the time when they're doing that, they're actually getting, in this particular, minerals and so on, because their eggs need minerals to lay from there. So they're not out every night hunting from there. Some of them, just to point out, and this is a moth that has been found in Madagascar, actually has barbs on the end of its proboscis, and it flies at night, and it will find a sleeping bird, and it will put the proboscis into the eye, the thing that closes, to hold it, the eyelid, into there, and then it will suck up the tears, because the tears have got salts and minerals in. Yeah. They'll also do it on humans. So just don't go to Madagascar.
Are there any varieties of butterfly that don't actually eat at all?
Yes. Yeah. Yeah. They're a bit like mayflies. When mayflies come out, they've got no mouth parts. Yeah.
Another question. I've seen on television various mammals that have been eating semi-fermented fruit.
Yes.
And you've got butterflies sitting on fruit there.
Oh,
Evidence of intoxicated butterflies.
Yeah, they're completely drunk. They will get drunk. Yeah, not in the way that we get drunk or animals get drunk, but they ingest it.
They smoke.
They drink. Yeah, they're nasty creatures. Yeah. So the reason I've taken a one on that, this is particularly something that only butterflies and moths have got. It's a mechanism. It is like keyhole surgery, and it's actually tremendously. I get quite excited about it, the way it works, because we can't actually work out how it works. So let's go on to another aspect of it, which is how do butterflies fly? Because they seem to do random jerks, don't they, most of the time? As I say, butterflies flutter by in terms of the way it kind of works. Well, this is a clear-wing butterfly. Let's go back one. There we go. That's a clear-wing butterfly, and the reason it's called a clear-wing butterfly is you can see through the wings. They're almost invisible for it, but it gives you a good idea of the structure of the wings. In theory, they're like bumblebees. If you work out mathematically, bumblebees can't fly because their wings aren't big enough. Butterflies, their wings are too big. However, it's fascinating to work out how they actually fly, because they seem like quite fragile animals, don't they? And yet they can fly quite well. They can fly long distances. And some of them won't do it tonight, but like the monarch butterfly has 4 or 5 life cycles. Starts in Mexico, works its way up to the north of America and into Canada, and then the 5th generation flies all the way back to Mexico again, and they start again. And you think, well, how do they know to do that? But that's a different story. So they can fly quite well and quite strongly, but most butterflies seem to be fluttering about all over the place. But we've got a video to watch in a minute or two, which actually shows it in slow motion as to how they fly. But it's fascinating because each of those wings can act independently, and the back wings are for downforce, and the front wings are for propulsion. And so they're almost swimming through the air. But the way they do it, they augment it. There's some vortexes around the edges which they can swirl and move around to keep in a windy place, to keep on track. But also they do what's called a butterfly clap. They bring their wings up, that goes right to the top there, and then they pull it open, which has a downforce, which forces the back wings down and the front wings forward. But it also creates a little vacuum, so it lifts the body up. And that's why it seems to be jerking all over the place. And so when a butterfly starts off, it almost certainly never flies straight. If you're heading for a pigeon on the road, make sure it's not looking at you, because pigeons can only take off in the direction it's pointing. Butterflies, they start off and they suddenly veer to the left or the right, depending on where the noise might be coming from or where they're concerned with from there. But that gives them an ability. It's a bit like somebody hopping and skipping and doing backflips down the road. Apart from the fact it looks a bit silly, you're not exactly sure predicting where they're going to go next. And so any predators that might have them have got a bit of a problem to do that. Their wings themselves are fantastic. This is called a blue morpho butterfly, and I've got one here. So what colour is it? Blue. Yeah. Turquoise, iridescent. If you can see how it does from there. Yeah, it's actually brown. Well, you wouldn't know that, would you? That the natural base colour of it is brown. The colouring comes from the scales, of which there are thousands of them. So if you look in here, you can see them in rows. 1 square millimetre, tiny little square, will have maybe 6,000 scales on it. They are phenomenally small, and they don't, sometimes they have pigments in them, sometimes they don't. Most of them, in the blues, the greens and the yellows, are actually reflecting light. So what happens is that the light comes in, and only the blue light is bounced back or reflected in that way. They, as you get nearer and nearer, you can see that they are all individual structures, and they're just fascinating. I'm just trying to, somewhere I've got the details about exactly how small they are. But if you imagine a human hair, the individual scales are smaller than the thickness of a human hair. Let me see if I can find the details. There we go. Okay. If you look at them through the microscope, you can actually see the scales have got like ridges on them. And in fact, when you get to the stage where they are quite close up, you can see those ridges a lot better. Those ridges they're spaced 0.00022. So 22 10,000ths of a millimetre apart. That's 1,000 times smaller than the width of a human hair. And these rows are so straight that the maximum difference they go out of line is 2 10,000ths of a millimetre. That's absolutely fantastic. In fact, no machines that humans have ever made have this type of accuracy. Can't get anywhere near that. Just imagine, that is fantastic the way it does it. What is even more stupendous to my mind is that these are accurately in rows, and they create the pattern on the wings. And the wings, when they're done, the patterns come out, and you'll see that they are different colours. They've got maybe an eye shape on it or something like that. You know, different shades of it from there. They're all done in these scales, and they're all done in minute fractions of millimetres, which go to make up the pattern when you see them. Not only that, when they're laid onto the wing, when they come on as part of the wing is all crumpled up in the chrysalis. So it's not even got a straight bit to start off with. It starts off all completely crumpled up and wrinkled and done. And when it comes out, it ends up 22 10,000ths of a millimetre in straight lines. And it's got ridges on it. And the reason it's got ridges on it is that they don't get waterlogged. So if a butterfly has a drop of water on it, it drops straight off. They're waterproof, which is amazing, isn't it? Let me just show you. It's about a 6 minute. Are we okay for time? Yeah, okay. This is about a 6 minute video.
Hello YouTube, I'm Nick.
So that's quite. The aerodynamics are fantastic.
One of the things that always amazes me about butterflies, they're so light, they have such a large surface area. How do they manage to get anywhere in weather conditions which are anything more than a breeze? Because they get blown all over the place.
They're incredible in the way they can manage that. And they've actually done studies with monarch butterflies in wind chambers. And they see the way, they've done it in slow motion, they can see how the wings react to it. And what happens is, with a bird or an aeroplane, it uses lift and it uses thrust from the back to get up into the air. The butterflies actually manipulates the air as it's going around it. So it's a bit like a downforce on a Formula One car or whatever it is. It actually moves the air, and its wings are big enough, like a big rudder. So if you imagine having a little rowing boat with a big rudder, you can almost spin it round, and it reacts to that. And some of them use it to their advantage, because there's a butterfly called the painted lady that you might have seen here. It doesn't overwinter here, it disappears. And it appears in Africa, 3,000 miles away. And nobody knows how they did it, because they're such until only about 15 years ago, a pilot recorded a whole, group of them flying past their window. And what they'd done is they'd picked up the jet stream. So they flew up high, 20, 30,000 feet, picked up the jet stream and got a pick down to the Atlas Mountains, and so on. So they are phenomenal. I'll talk about monarchs maybe another day, but we have a GPS tracker that takes us, well, we get lost in a house quite regularly because it's got a different postcode or something. These can detect a monarch butterfly from Canada, can get back to its base in Mexico within 10 feet of where it is, and things take over. Very quickly, this is a peacock butterfly. Amazing kind of colours and things from there. It looks like an owl or a bird of prey. When its wings are closed, it looks like a dead leaf. And it hibernates over winter. So it hibernates in sheds and things like that. You'll find it, yeah. You'll generally find its wings, because if anything does eat them, they don't eat the wings, they eat the body. And mice are particularly fond of eating peacock, bodies. There's two things that happen if a mouse, because they're not totally dead, they're just dormant, so they're quite often from there. If somebody startles it, it will open its wings, and suddenly you'll see an owl coming to it. The other thing it does, you see where the body is, it's got hairs associated with it. When it opens its wings, those hairs make a noise like a frightened mouse, which frightens the mouse off. Okay? Now, that's one of the reasons I believe in creation rather than in adaptation, because to be able to do that, to be able to think, I'm going to look like an owl, you've got to know what an owl looks like. You've got to be able to program thousands of scales to look like that, and then you've got to say, I know what a frightened mouse looks like, I'll make that noise with the hairy body that I've got from there. That seems to me too difficult to actually do at random with evolution from there. Let's just have a look very quickly. Are there any fossil butterflies? Well, the answer is yes, there are. There's quite a few. Here's some bits of it. An evolutionist would say this, that butterflies evolved at the same time as other insects, which is about 400 million years ago. Yeah? Of course, that was before plants evolved. So plants evolved about 120 million years ago. Okay, and animals, mammals, about 56 million years ago. So my question is, why did butterflies have proboscis when flowers weren't around? It was another 280 million years before you got a flower. It does seem a bit odd to me. And also, why do they need ears? We were talking about moth ears, when bats didn't arrive until 350 million years after they'd been evolved. So that is a question that I have, that the timescales just don't kind of work out properly. Here's a fossil moth. Okay, it's been dated at about 380 million years. Okay, it looks almost perfect. It looks almost exactly the same as the thing I've got. It actually isn't that far away from this particular moth, which looks identical. Prodryrus persephone is the same moth that was fossilized 380 million years ago. And it's almost identical. So you're thinking, what's happened in 380 million years, or whatever it is? Why hasn't it changed? Why is it still exactly the same as it was? And these are some of the reasons why I believe in creation. First of all, butterflies and moths are way, way over-engineered. the proboscis, the eyes, the wings are such that they don't need it. Why do they need all that complexity? And yet they are there. And it's not just adaptation of the fittest, it's adaptation of the most complicated. They don't need all that, but they were engineered in that way. The evolutionary timeframes are all wrong. It doesn't make sense to me. And there's too much interdependence on so many different parts working together, and evolution works on single random changes, or a bit that gets randomly changed. You need more than one random change to work it all out, because you've got to have everything working before it can actually make a single butterfly work. So that's another reason why I believe in creation rather than evolution. Some parts, such as the wing patterns, would require knowledge by the butterfly that it could never have, like the peacock one. From there. By the way, some of the wing that we're talking about, the morphos, when you look at it, it shows different patterns and colours. What they've got is they're building a blast patch for wartime, built on exactly the same structures as scales from a butterfly, so that if somebody gets blown up by an IED or something, they can tell the severity of the force by the colour that the patch goes to, because it will go out of kilter and it will then turn into different colours. So that is something that they've learned from butterflies. But it's just I think, impossible for a butterfly to think, I'll imagine what an owl is, I'll imagine what a mouse sounds like from there. Their genetic structure hasn't changed. If you take the genetics, the DNA from that fossil, and do the thing, they're more or less identical from there. There's no fossils with intermediate forms anywhere. And there's no evidence of non-flying animals becoming able to fly. No evidence anywhere in evolution. So insects, bats, birds, pterosaurs are all flying insects, animals that have happened. There's no evidence of where they came from and how they did it. So may my meditation be pleasing to him. I will rejoice in the Lord. We'll continue this next. I'm sorry it took a long time. I get really excited about this, but it's something that I find. Next time we're going to be talking about what happens to turn a caterpillar into a butterfly and how it actually works. And they've been doing CT scans inside the caterpillar, so you can actually see how it kind of works. But from there, let's just pray, shall we? Father, we thank you that when we look at just a simple thing like a butterfly, how complex, how beautiful, and how wonderfully it's been created. And we want to say like we sung before, we stand in awe of you. Amen.